Hello everyone. I welcome you all for the lecture series videos of control functions of the hydraulic system. So in the previous video, we have discussed about the 4 by 3 direction control valve and its construction and working procedure. In this video, we are going to discuss about the various center positions of the direction control valve. So let us have a discussion. So the number of center positions configurations are available for the direction control valves are. So in the previous video, we have discussed the center positions, all the ports are blocked and all the positions are open. So like that, many center positions are available. So here I have listed the center positions which are commercially available for the direction control valve. The first position is closed position. Second is open. Third is tandem center. Fourth is floating center. Fifth is regenerative center. Each one of these cases having its own applications, and we have to discuss about the symbols and its application. So here I have listed all the center positions for the four-way valve. So the first symbol is closed symbol. In this closed symbol, we know that for all these valves we have 4 ports, and the center position depends to vary. The 4 ports are PTAB. So stands for pump port, T stands for reservoir port or tank port, A stands for actuated position of an port of an actuator, B stands for retracted position or unactuated position port of an actuator. Under this closed center, all the ports are completely blocked. So the actuator has to maintain the position what it is. So no movement in the actuator because the pump port is completely blocked, tank port is blocked, and all the ports are blocked. No flow between the input of the valve and the output of the valve. And the second position, open center, here all the ports are open. Pump port is connected to A and B and the tank port. It is used to hold the actuator at very high force. Whenever we want to hold the actuator at when the very high force is actuated, this position can be enabled. And the third is tandem center. In the tandem center, port A and B, actuator ports are A and B are completely closed, and the pump port is connected to the tank port. So whenever there is no actuation in the valve, we don't want to actuate the cylinders. The center position comes into operation. The pump is completely pumping the fluid from the reservoir. If it is not properly used, it creates an excessive pressure and finally it tends to busting of tube, which leads to accident. We use this tandem center, the oil from the pump, again it is pumped to the tank because the pump port is connected to the tank or reservoir, which will uh, reduce the operation of pressure relief valve. If at all we are not using pressure relief valve, this comes into operation, pump port is connected to the tank port. Then the other configuration is floating type of valve. In this valve, a pump port is blocked and port A and B is connected to the tank. So the oil from the actuator, both the sides, piston side and rod side, will be completely drained to the tank with the floating center. The name itself indicates float. All the oils are completely drained and it is ended to the tank. In the other hand, pump port is completely blocked. And the final port is called a regenerative position. In this position, pump port is connected to the actuator port A, and B, actuator port B is connected to the port A. So initially the pump is allowing the fluid to the actuator port A. The actuator will make an extension. During extension, the oil from the rod end, it is coming back to the port B, and the oil is forced. If it is returning to the reservoir, some of the energy may be wasted. That forced high pressure oil, again it is pumped, send it to the uh, actuator port A, which will increase the pressure of the fluid. So since the energy may not be wasted, it is, again it is used. That's why it is called a regenerative center. In the time, the tank port is completely closed. So these are all the various configurations which will be used to various applications. And coming to the center position, which affects the direction control valve characteristics and overall efficiency of the system. So depending upon our application, we have to uh, select the system. For each style, it provides distinct operating characteristics that allow the hydraulic system designers to obtain the maximum performance of the system. And these are all the references. Fluid Power by Anthony Esposito, published by Pearson, Delhi, the year 2003. And Fluid Mechanics and Hydraulic Machines by R.K. Bansal, published by Lakshmi Publications, New Delhi, the year 2021. So in this video, we have discussed about the various configurations of the center positions of the direction control valve. Uh, in the upcoming video, we will discuss the remaining things. So I hope this video is useful for you. Thank you for watching this video.